So we ask, okay, we are going to learn how to use inverse of a matrix to solve simultaneous equations. So we are given this system of linear equation. So we're asked to solve using that method. I'm going to form a matrix with this. That's matrix multiplication. So something times something to give us something. Yes. So I'm going to use this to form a matrix. So the first bracket is the matrix that has the coefficients of the variables, which are A1, B1, C1, A2, B2, C2, A3, B3, C3. So why the variables are X, we'll form a column matrix with that. So as you can see, if I want to get this, it's like this times that plus this times this plus this times, which gives us the first equation, and it will give us an answer which is K1. So that same way, this times this will give us this, and it will give us this K2. Finally, this times this, which is this, will give us an answer which is K3. So we'll form a matrix, and remember what we are looking for is this X, Y, and Z. Therefore, what we are looking for, let's make it the subject of formula. X, Y, and Z will be, okay, let me just explain something before I go to this. Assuming we are asked to find X given this, we divide both sides by A, so B over A. And you know in mathematics we can write B over A as A raised to power minus 1 times B. So if you compare, this is A, this is X, and this is B. We are looking for X, which is this. So this one goes here to be raised to power A1, B1, C1, A2, B2, C2, A3, B3, C3. So raised to power of minus 1 times B. Our B is K1, K2, K3. So meaning that for us to solve for the variable X, Y, and Z, we need to get the inverse of this, and after multiply by this, whatever that will get will be a column matrix. So we'll compare. The first one becomes the answer, the second. So that's what. So the main thing is for us to get the inverse. Whatever that we've gotten, we'll multiply it by this. So let's solve one example using that. So we are given this. We are asked to solve by inverse of a matrix. So the first thing I have to do is to form matrix using that. So I have 2, 3, 1, 1, 3, 4, 3, 1 minus 2. That's my first matrix times our variables equals 6, 8, 2. So that's the first thing. So the second thing is to make this the subject of formula. So we have X, Y, Z. This becomes the inverse of a matrix. This 1, 3, 4, and 3, 1 minus 2, all raised this minus. So our main target is now to find the inverse of this. And remember, to find the inverse of a matrix, the inverse of it, if we call this matrix A, the inverse is always the adjoint. Adjoint over the determinant is our inverse. And remember, for this to have an inverse, the determinant will not be 0. So we'll first find the determinant of this. So let's get the determinant. So determinant of 2, 3, 1, 1, 3, 4, 3, 1 minus 2. So let's, using the first row, I have this 2 times minus 10 minus 3 times minus 14 So finally, plus 1 times 1 minus 9 is, so that's, let's find the determinant. This minus 20 plus this to 42 minus 8, so this is 14. So we've gotten the determinant. So the next thing is to get the adjoint, and for us to get adjoint we need to find the cofactor matrix. So let's get the cofactor and transpose it. The transpose is the adjoint. Or meanwhile, before we solve for cofactor, we need to get the minor. So let's find the minor of this. So let's get the minor of this matrix. So the first one, M11, which is the determinant of 3, 4, 1, minus 2, which is minus 6, which is minus 10. Why M12? So for this, M12, so we'll have determinant of 1, 4, 3, minus 2, which is minus 2 minus 12 is minus 14. M13 is 1, 3, 3, 1, which is minus 8. M21 is second row first column, which is 3, 1, 1, minus 2. So we have minus 6 minus 1 is minus 7. M22, that's second row second column, so second row second column, which is 2, 1, 3 minus 2. So which is minus 4 minus 3 is minus 7. We have M23, second row third column, so we have 2, 3, 3, 1, which is 2 minus 9 is minus 7. M31, that's third row first column, which is 3, 1, 3, 4, which is 12. 12 minus 3 is 9. M32 is third row second column, so third row second column, which is third row second, which is 2, 1, 1, 4. So which is 8 minus 1, 7. M33, which is third row third column, so third row third column, which is 2, 3, 1, 3, which is 6 minus 3 is 3. So we've gotten the minor. So the cofactor is the matrix of the minor, but you alternate in sign. So this is positive. 1 plus 1 is an even number. Do you remember that the matrix of minor with alternating signs is the cofactor? So we see that the cofactor matrix is matrix of the minors, but you need to alternate in sign. So this 1 plus 1 is an even number, so the sign remains the same, but this is an odd number, so the sign changes to plus. This even, so it remains the same. Add this odd, so this changes its sign. This is even, the same. This is odd, changes in sign, so positive. This is even, remain the same. This is odd, changes in sign. This is even. So this is my cofactor matrix. So the next thing is the adjoint. The adjoint is now the transpose of the cofactor matrix. So the adjoint of matrix, which is cofactor transpose, we transpose this to be minus 10, 14, minus 8, 7, minus 7, 7, 9, minus 7, 3. So these are our adjoints. So our inverse, the inverse we are looking for is now what? The adjoint over the determinant. So our determinant is 14. So we know we can write this as 1 over the determinant times the adjoint times adjoint. So we have 1 over 14 times our adjoint is minus 10, 7, 9, 14, minus 7, minus 7, minus 8, 7, 3. So which is, so you know this scalar multiplication will multiply each by that. So this times that is minus 5 over 7. This times this is half. Why this times that is 9 over 14. So the next one is this times this is 1. This times that is minus half. This times that is minus half. Why the last row? This times that is minus 4 over 7. This times that is half. Why this is 3 over 14. So this is the matrix. So that's the matrix. So this is my inverse matrix. So we'll go back. Remember this as that. So we'll multiply by 682. So therefore the xyz we are looking for is now this minus 5 over 7 half 9 over 14 1 minus half minus 4 over 7 half 3 over 1 over 14. So this matrix, the inverse matrix times 6, 8 and 2. So that should be our final. Once we multiply it, that becomes our final answer. So let's multiply. This times that is minus 30 over 7 plus this times 8 is 4 plus 2 times that is 9 over 7. So this x, y, z. So 1 times 666 plus this times that is minus 4. So we'll write minus 4. Minus 4. This times that is minus 1. So we are done. Let's move to the third row. So this times 6 is minus 24 over 7. This times that is plus 4. This times that is plus 6 over 14. So let's add the LCM. The LCM of this is 7. This is minus 30 plus 28 plus 9, which is this minus 2 plus 9 is 7. 7 over 7 is 1. So why this is 6 minus 5 is 1. This is the LCM is 14. 14 in that 2 times that is minus 48 plus 14 times that this is 56 plus 6, which is this is 60. This 62. 62 minus 4, it is 14. 14 over 14 is 1. Therefore, from this x is 1, as you can see. y is 1 and z is 1. So that's our answer, what we are looking for, the value. You can go and cross check. Let's substitute the values. 1 1 1 6 1 1 1 8 1 1. So that's how we solve using inverse of a matrix method. Thank you.